Coming to the next topic, that is connected components. So let us see in the graph what is the connect components and what are the bi-connected components. So actually all these connected, bi-connected are all these the applications of, these are nothing but applications of depth first search. So that depth first search is already explained in the previous video, and the applications for depth first search are unidirected graphs, or it may be or you can unidirected graphs or directed graphs. So a depth first search may be constructed by using unidirected graphs or directed graphs. So unidirected graphs are nothing but a connected components, articulation points, bridges, and bi-connected components. So these are all come under the unidirectional graphs. And coming to the directed graphs are nothing but the cyclic or acyclic graphs, topological sort, and strongly connected components. Strongly connect. If a connected components is everything will be connected, then you call it as, means if the connected components if you are given direction to that connected components, then you call it as a strongly connected components. Okay, so these are all applications of depth first search. Now let us see what is this connected components and bi-connected components on this topic. So let me write let's first discuss about the connected components. So what is a connected component? Let me write the definition. An undirected graph means there is no direction, you can go any you can meet any vertex. An undirected graph is called a connected graph. So whatever the undirected graph, if you call it as a connected graph, if there is a path between any two vertices, so then you call it as a connected graph. When you say it is a connected graph, so any undirected graph, okay, so if any undirected, this is undirected graph, there is no direction from one vertex to another vertex, there is no direction, you can go this way or you can go this way, like that. So an undirected graph is called a connected graph when you say it is a connected graph. If there is a path between any two vertices, yeah, this is a path, there is a path between two vertices, then you can say this is a connected graph. There is a path between any two vertices, then you can say this is a connected graph. Okay, so now let us a connected component. What do you call a connected component? A connected component, so this is a connected graph, I said. If there is a path between any two vertices, then you call it as a connected graph. Then what about the connected component? A connected component is a subgraph. You are just call it as a subgraph in which any two vertices are connected. So we just call it as a subgraph. In there, any two vertices are connected to each other by paths. Okay, here we connected any two vertices to each other by a path. Path means edge, and which is connected to no additional vertices of the supergraph. Supergraph is the main graph. So that is about the connected components. So let me take the example for this. What is the connected components? The example for this, 1, 2, 3. So this graph is one vertex is connected to another vertex with the path. A path is there. So a path exists between two vertices, then you say it is a connected graph. 2, 3, 4 and 6. So these are all the different graph connections. So these are all the examples for the connected components. So let me explain the algorithm for this connected components. Algorithm for connected components. Let us see the algorithm for connected components. So what is that? So you just take the connected component, so of graph G. Let's take graph G. So first step, for each vertex, V is a vertex. That vertex should belongs to graph of any vertex. Second step, so you have to make set of vertex. And third, for each edge U comma V, U is unvisited vertex and V is a visited vertex. Both unvisited and visited vertex belongs to G dot E. Then if find set of U, that is an unvisited vertex, whatever we are searching for, that unvisited vertex is not equal to find set of visited vertex, then you have to make union, because you have to join both visited and unvisited. So you have to be joined, U and V. So if both are not equal, and then you just join union of U comma V. You have to merge that. Suppose same components are there. Component U comma V. Suppose the same component U comma V is there. Then if find set of U is equal to find set of V, when visited and unvisited both are equal, then you have to return true. Or else return false. So this is the algorithm for the connected components. Thank you.